Estimation strategies or estimating strategies. I'm going to give you 3 different estimating strategies that you can use in different situations. Some of the benefits of estimating are when you're calculating things with decimals, it helps to see if your decimal is in the correct place. Sometimes all you need to do is estimate, and you don't have to actually do a full calculation at all. For instance, if you wanted to go buy a new video game system or something, and you wanted to know if you had enough money left on your credit card or if you had enough money in your bank account, you don't need to know the exact amount of money. You just need to know if you have close to enough amount. Also, if you're leaving a tip at a restaurant and you need to know what 15% or 20% is, it's not necessary that you know the exact amount. It's just something close. For instance, I was eating lunch today, and my bill came to $10.92, and I wanted to leave about a 20% tip. I know that's really close to $10, so I've just left a $2 tip. So a little below 20%, which I was okay with. And it took me, 2 seconds to figure out, so estimating was definitely important there because I didn't have to do the full calculation. The first way to estimate, we're going to call rounding. And to round, we're going to take 3.27, and I believe most of you have rounded before. If you're rounding to the nearest whole number, which is what we're going to do, we need to look at the next digit, so the 2. If that digit is 4, 3, 2, 1, or 0, so 4 or below, this number stays the same. The number you're rounding to stays the same. If this number, the 2 in this case, if it were a 5 or above, 5, 6, 7, 8, or 9, then this would round to a 4. Okay. So what we do is we put this little symbol here, and that means approximately equal to. If we were doing something like 5 minus 3, we would say that equals 2, because that is 2. But now when we're rounding, I'm going to turn this 3.27 into a 3. I'm rounding it to a 3. And I'm going to turn this 0.88. That's closer to 1 than it is to 0, so I'm going to say a 1. And so that's why I use this squiggly symbol here to show approximately equal to. So 3.27 minus 0.88 is approximately equal to 2. 3 minus 1 is 2. So that's a good strategy to use. And let's see if we can practice. I'm going to put up 3 problems. I want you to pause, try them yourself, and then you can unpause and see if you did it right. Problems are going to be 1.75 plus 0.92. The next one is going to be 4.34. Now let's make that 14.34. Minus 7.8, and the third one is going to be 4.9 times 6.25. Alright, so pause and try those out. Alright, so we're going to set this approximately equal to, so 1.75 is close to 2, or closer to 2 than 1. 0.92 is closer to 1 than 0, so we have approximately equal to 2 plus 1, which is 3. For the second one, 14.34 is close to 14. 7.8 is actually a little closer to 8. So we have 14 minus 8, so we have 6. 4.9 is really close to 5. And 6.25 is really close to 6. And so we know that 5 times 6 is 30. So that is how you round using estimation, or sorry, how you estimate using rounding. The second type of estimation strategy is called front-end estimation. And we use this often when we are adding or subtracting decimals. So let's give you an example of that. If we, let's say we got some money, we're buying things. So we bought a a deck of cards for $4.39, and then we got a pack of gum for $1.49, and then we also bought, what did we buy for $2.95? I think it was an ice cream bar. So we have all these things, $4.39, $1.49, and $2.95. And we want to see if we have enough money, or we want to make sure the cashier rung us up correctly. So we want to estimate in our minds before we get to the cashier how much money we think this is going to cost. So using front-end estimation, we're just going to deal with the front end first. Okay, everything past the decimal. Remember, sorry, that decimal is right there. So we have $4 plus $1 plus $2. So that's going to be $7 so far. And now we can deal with this other stuff here. Now we know 39 plus 49, 39 cents plus 49 cents is pretty close to $1. Okay, it's actually more like 90 cents or 88 cents, but that's pretty close to $1. So we're just going to say that's $1. And then 95 cents is very close to $1 as well. Okay, and so what we have is we have that $7 down here plus $1 plus another dollar, which is $9. Okay, so we know if the cashier says that it's like $9.15 or $8.95 or something like that, we're pretty confident that they've given us the right amount. However, if the cashier says, oh, okay, that'll be $18, we'd be like, wait a minute, I think you didn't ring this up correctly. Okay, or if we had, $10 in our wallet, we'd figure pretty confident, or we'd be pretty confident that we'd have enough money. Okay, so that's front-end estimation. Let's have you try out one of these, let's say. Front-end estimation. Let's say you wanted to order some food, and so you ordered a taco that costs $3.49, and you also ordered some juice, costs 89 cents, and then you also ordered some yogurt, costs $1.39. Okay, use front-end estimation to figure out the answer, and then unpause to see if you were close. Okay, so front-end estimation, we've got the 3 and the 1, that's $4. Then we have 89 cents, that's pretty close to $1. So we'll say that's $1. And then this 49 plus 39, kind of the same as the last time there. Let's kind of bring those together. That's going to be about $1. All right. Remember, it's estimation. It doesn't equal $1 exactly, but it's approximately equal to $1. So altogether, we have this $4 and this $1 and this $1, and that leaves us with $6. About $6. Okay. Let's put approximately equal to $6. All right, the last type of, where am I? Here we go. The last type of estimation is compatible numbers. This is helpful a lot when you're using division. Okay, so division. If I'm doing $50 and 25 cents, and I'm trying to divide that by $7.95, right? So in this case, maybe you have $50.25 in your piggy bank, and you want to go buy DVDs that are on sale at Best Buy for $7.95 each. You want to know about how many DVDs can you buy. That's an about, right? Well, we can't really use rounding here, because rounding 50.25 to 50, dividing by 8, that's not an even number. We could round it there. We could say, well, that's about 6. Okay, that would be kind of like a rounding situation. But something that we can do here is called compatible numbers, where we find numbers near 50.25 and 7.95 that are divisible, right? So 7.95 is real close to 8. So that's nice. So what number is 50.25 close to that is divisible by 8? So we could choose maybe 48 divided by 8, maybe 56 divided by 8. Okay. Either way, we get a number that works. So we get around 6. Oops. So around 6 or 7 DVDs. Okay. So you can try this one. And let's say you have $61.80. And how many CDs can you buy if each one costs $15.95? Pause it, try to get the right answer, and unpause, and you'll see if you're right. Okay. So I'm going to try to find compatible numbers. Well, this is close to 15 or 16. Because I've practiced this a lot, I can just kind of tell that 60 is divisible by 15 nicely. And so we can say we can get about 4 CDs. I think if you actually did the calculation, it's very close to 4. It's probably in the high 3s, maybe a 4.